Hey YouTube, this is my second video on rational expressions. In the last video we talked about how to simplify them, multiply them, and divide them. What we're going to focus on in this video is how to add and subtract them. So basically what I'd like to do before we kind of move into this is review how we add or subtract fractions in the first place. And if they have the same denominator, I know I'm using just variables here, variable values, but basically what we'd say is if they already have a common denominator, then the common denominator stays the same, and then what we do is either add or subtract the numerators essentially. So when we add or subtract rational expressions with the same denominator, you notice that the note says here, adding or subtracting the numerators is the first thing we do, and then placing this result over the common denominator and simplifying if possible. So this is essentially what we're seeing here. We added, in this case, the numerators, and then we put it over the common denominator. And if we could have simplified this by finding common factors, we would have done it at that point. So let's take a look at just this example that I have here, and then we'll talk about how we do this with different denominators. But you'll notice the first example, basically, we have x over x plus 1 minus 3x plus 2 over x plus 1. And the point that I would like to make is that we already have a common denominator. So what we're going to get really is still over x plus 1. That kind of just stands alone. So what we say we get on top, though, was the difference of this numerator and this numerator. And you notice that I did put parentheses around both these numerators because what I want to see is this. We say all of this minus all of this, because we are going to have to do some simplification here. So we get x minus 3x plus 2. This is all over x plus 1. Simplifying by combining like terms here, looks like we get negative 2x plus 2 on the top. We get x plus 1 on the bottom, and actually I notice a common factor on the top, so we should factor that out and try to simplify this. But when I do, I take out the negative 2 here. I get left with x minus 1, and this is still over x plus 1. Had this been an x plus 1, we probably wouldn't have been able to, well, we would have been able to simplify it, but we say that this is our final form of this, which is the same thing as this. So now considering what one does when you don't have a common denominator, say rational expressions that have no common factors in their denominators can be added or subtracted by using one of the following properties, starting with the one that you see here. So let us consider that a over b plus c over d exists, and we say that we have no common factors between the top and the bottom here, but b and d are not equal. Okay, b is not 0 and d is not 0 as well. But essentially what you're going to see is, well, then the common denominator would just be the product of those two things. That's like kind of saying if I took 1 over 2 plus 1 over 3, then my common denominator would be 2 times 3. I mean, that's just the way it's going to be. As a matter of fact, what we'd do is we'd say we'll take everything over here times 3 over 3, and then we say take everything over here 2 over 2, and we'll multiply these out. So essentially what we get is we get 3 times 1 plus 2 times 1 all over 6. So basically 3 6 plus 2 6 in this case. We would say 3 plus 2 all over 6. So we get 5 6 in that case. But this method works every time. You'll notice essentially what this says is that the product of the two denominators is a very, very good common denominator between the two. And you'll notice what we get on the top here. We say AD plus BC. The way that we're getting this is basically by admitting that we would have to take both of these things over here, the top and the bottom, times D. So here's our AD. We take everything over here times B over B. And that's where we're getting the BC on top, with the common denominator being BD. So it says the denominator BD is the product of the factors in the two denominators. And because we're considering rational expressions that have no common factors in their denominators, then the product BD gives the least common denominator, the LCD. Okay. So in this instance here, I notice that I have 3 over x plus 1, or 3 of these x plus 1/8, plus 5 of these x minus 1/8. So according to what we've got written here, all I would need to do is say, well, let's do this. Let's take everything over here times an x minus 1 on top and bottom. X minus 1, x minus 1. Let's take everything over here times x plus 1, x plus 1, which is really just multiplying by 1 on each side here. But what I notice is that I would get this. I would say, well, this is x minus 1, x plus 1. And on top, I would have 3x minus 1. And over here, I'm going to get this. I'm going to have 5x plus 1. Plus 1, so 5. And we'd say this is also over x minus 1, x plus 1. The thing is that I just feel like this is a very, very long way to go about it. So really what we want people, or what we push people to be able to do, is more quickly use this property that we see here, which says, well, I already know that my common denominator is going to be the product of these two factors in both denominators, if they don't share any common factors. So it'll be x plus 1 times x minus 1. And then over here we'd have to take this 3 times this one's denominator. So I would get 3x minus 1. I got that from over here. And in this case we're adding. It's a sum on top. I'll just borrow that there. And we say over here I would get 5 times this one's denominator, which 5 times x plus 1 is that, okay? So the same thing that I have listed here, it's just that I've skipped straight to a step further down in the process. It cuts out some work. So the last thing we do need to do here that we're responsible for is to simplify this. So I'm going to get 3x minus 3 on the left plus now 5x plus 5 on the right, and this is still over x plus 1, x minus 1. And so finishing this off, it looks like combining like terms, we get 8 x's on top, and a negative 3 and a positive 5 is a 2. This is still over x plus 1, x minus 1. And I do want to say this, we can factor the top, which we should do, because what we want to do is we want to write this in the simplest possible form. So I get 4x plus 1. And this is all over x plus 1, x minus 1. And I notice that nothing has a common factor, or the top and the bottom share no common factors. So in this last example, essentially what I want to look at is, okay, well, what if we needed to find a least common denominator, and the denominators actually share some common factors, okay? So this is basically going to kind of point out a method for doing this, but to determine the least common denominator, essentially what we're going to do is we're just going to factor the denominators. Factor each denominator completely is what this says, and then list the factors of the first denominator. And actually we don't need to list the factors of the second one because it's sufficient to list the factors of the first, but all I really want to do is this. Determine the least common denominator for these two rational expressions. Well, what I see here is I've got 3 over x squared minus 6x minus 9, or plus 9. So to factor this into a binomial product here, product of two binomials, we'd have x and x in front to get our x squared. We'd say, well, two factors of a positive 9 that add up to be a negative 6 here would be a negative 3 and a negative 3. Whereas over here, I'd say, well, if I had 7 over x squared minus 9, I've got x plus 3, x minus 3. So what we want to know is, well, what's the least common denominator between these two things? Well, I notice already that, this has a x minus 3 and this already has an x minus 3. What I need to do is give this one over here another x minus 3, whereas this one over here needs an x plus 3. So this is where listing the factors of the first denominator makes sense. We say, well, the two factors are x minus 3 and x minus 3. But number 3 says, add to the list in step 2 any factors of the second denominator that do not appear in that list. So I'm looking at the factors over here, and I have 2 x's minus 3. And I said, well, are there any things over here in this denominator that don't already show up over here? And I notice that x plus 3 is what shows up. So our LCD in this case is going to be x minus 3, which were from the list of things in our factors in our first denominator. And then I would add this into the list because I would say that, it needs that as well. But we could basically, if we needed to add or subtract things, I could say, well, then in that case, I'd say, well, here's my least common denominator. I'll multiply the top and bottom over here times that. And then over here, I'll take both sides here, both top and bottom, times x minus 3. And then now everybody has 2x minus 3's in the bottom and an x plus 3. So adding and subtracting rational expressions that have different denominators. It's not that it's tricky, it's just that there are a lot of steps involved. So number 1 is going to be this. Let's find the LCD of the rational expression. And again, the first thing we want to do is just, let's go ahead and factor everything that we can. We say on top we have x over, now this expression does indeed factor. I notice this is a trinomial where a is 1. So I have x and x give me the x squared. Two factors of 25, positive 25, that have to be negative 10 here are going to be a negative 5 and a negative 5. And we are subtracting off now x minus 4, and I'm going to put that in parentheses. But this is, over here factoring this out, we get 2 times x minus 5. So again, we say, well, what are the factors of each expression? Well, I've got 2 factors over here, and I've got 2 factors over here. And in terms of, well, what am I going to need to do here? Well, number 2 says rewrite each rational expression as an equivalent expression whose denominator is the LCD. So remember, the LCD, least common denominator, is everything that was in the first denominator, so x minus 5, plus any things that were not present in the first denominator from the second denominator. So I notice that this one has a 2. I need to add in a 2. And also this, I'd say, well, over here, I already have an x minus 5, and this one already has an x minus 5. It was already listed here. So our LCD is this right here. So again, I'm going to reread number 2. It says, rewrite each rational expression as an equivalent expression whose denominator is the LCD. And to do so, it says, multiply the numerator and the denominator of each rational expression by any factors needed to convert the denominator into the LCD. So this is our LCD here, just gotten by listing out factors of the first denominator plus any that we're missing from the second denominator. What I notice here is this. The first denominator already has 2x's minus 5. So I still need a 2. So what we're suggesting we do here is we'll take the top and the bottom times 2 over 2. Well, we'll take it times 2 over 2, but take the top and the bottom both by 2. And over here, I noticed in my list here, this one has the 2. This one has one of the x minus 5s. We need another x minus 5. And we multiply on top and bottom, like so. So step 3 says, well, let's add or subtract the numerators, placing the resulting expression of the LCD. Basically, at this point, what we're saying is, I already acknowledge that my least common denominator is going to be x minus 5 times that 2. And then over here, I notice that I'm going to need 2x. So I get 2x, and that's everything on the left here. Now minus everything on the right, and everything on the right is this x minus 4 times x minus 5. So the last step basically is, if possible, simplify the resulting rational expression, which I do want to do. So I am going to put braces around this one, and the reason why I say that is because I want to FOIL this out. I actually want to find an expression for this. So we get 2x on the left, minus, now in brackets we get x times x is x squared. X times negative 5, of course, negative 5x. Here we're going to get negative 4x, so we get total negative 9x when we sum those together, combine like terms, and then we say plus 20. And the reason why I chose to put those in braces is because you'll notice that it has a negative out in front of it. So when we distribute this negative throughout, it basically is going to switch everybody's sign, and what we end up with is, now I'm going to drag this over here. We get 2x, and we would say minus x squared plus 9x minus 20. And you notice that I'm just switching the signs on all of these. Oops. And this is still all over 2x minus 5x minus 5. So last but not least, we'll go ahead and combine like terms in the numerator here. I notice that our negative x squared should probably be listed first. And we have a 9x and a 2x, which gives us 11x. So we say plus 11x. Then we say minus 20. And this is all over 2x minus 5, x minus 5. So at this point, I'm going to say, well, what we should do is try to factor the top here. And I'll just be honest with you, it doesn't factor, at least we could factor a negative 1 out in front, but it doesn't factor enough for this to cancel out any factors with the top and bottom. But that is essentially the method we use to find a least common denominator between two fractions that don't have a common denominator and possibly share common factors. Cheers.